Hello students, in this video we are going to discuss 3.1, 3.2 and 3.3 from current electricity chapter 3. The storage battery of a car has an EMF 12 volt if the internal resistance of the battery is 0.4 ohm. What is the maximum current that can be drawn from the battery? So generally, if there is any external resistance like this, here it is connected to storage battery and with internal resistance connected like this. So this battery EMF here is nothing but 12 volt and internal resistance small r is equal to 0.4 ohm. It is external resistance. So the given values here, internal resistance 0.4 ohm, EMF of the battery 12 volt. Okay, that is the data given to us. What we need to find out, what is the maximum current that can be drawn from the battery. Here the current will be maximum if external resistance is 0. If this external resistance is 0, then the current will be maximum. So generally the formula for electric current I is equal to E by total resistance. Total resistance is nothing but external resistance plus internal resistance. It is the formula for the current passing through the circuit. Now here, if R external or R is equal to 0, then I value will be maximum. So I maximum is equal to E by small r, that is internal resistance. That is equal to 12 divided by 0.4. This is equal to 30 ampere. So this is the maximum current passing within the circuit or drawn from the battery. That is possible if external resistance is 0. If external resistance is not 0, then it will be minimized. The current won't be 30, it will be less than 30. Coming to 3.2. A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, so what is the resistance of the resistor? That means external resistance we need to find out. And what is the terminal voltage of the battery when the circuit is closed? Here the values given. E value is 10 volt, the battery of EMF. So we can take the circuit like this. It has some internal resistance. E is equal to 10 volt and internal resistance small r is equal to 3 ohm. It is connected externally with some external resistance R, and current passing in the circuit I is equal to 0.5 ampere. That is the data given. So current passing through the R is 0.5 ampere. Small r is equal to 3 ohm. We need to find out the resistance of this resistor. So capital R we need to find out. It is one of the subpart. And again the terminal voltage of the battery also we need to find out. For example, if you are taking this is the point A and it is point B. So the terminal voltage, that means the voltage between A and B, we need to find out. First of all, coming to the formula for electric current, I is equal to E by R plus small r. So from this we can write I is 0.5 is equal to E value is 10 divided by R plus 3. From this R plus 3 is equal to 10 by 0.5, that is equal to 20. From this R is equal to 17 ohm. So this is external resistance connected. And one more sub question. The terminal voltage of the battery. The terminal voltage here VAB is equal to I into R. I value is we have 0.5 and R value is 17. So we will get 8.5 volt. So this is terminal voltage of the battery. At room temperature, the room temperature is given as 27 degrees Celsius. The resistance of heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm? Given that the temperature coefficient of the material of the resistor is 1.70 into 10 power minus 4 degrees Celsius inverse. Here the values given. When temperature T1 is equal to 27 degrees Celsius, its corresponding resistance R1 is equal to 100 ohm. When R2 is equal to 117 ohm, that is 117 ohm, its corresponding temperature T2 we need to find out. So what is the temperature of the element if the resistance is found to be 117 ohm? And the given alpha value, the temperature coefficient of resistance alpha is equal to 1.7 into 10 power minus 4 degrees Celsius inverse. Here if you observe, with compared to R1, R2 is increased. So T2 will be more than T1. So we know that as temperature increases for a conductor, its resistance increases, its resistivity also increases. So now here resistance is increased from 100 to 117. So temperature will be raised from 27 degrees Celsius to some other higher temperature. So the T2 we need to find out. So what is the formula for final resistance? R2 is equal to initial resistance into 1 plus alpha, here T2 minus T1. Here temperatures are in terms of degrees Celsius. But here we are taking the difference, so either we are taking in terms of degrees Celsius or in terms of Kelvin, it won't affect the answer. So 117 is equal to 100 into 1 plus 1.7 into 10 power minus 4. So T2 minus 27. Here 117 is equal to 100 plus 1.7 into 10 power minus 2 into T2 minus 27. Here 100 comes to left hand side. This one will be 17 is equal to 1.7 into 10 power minus 2 into T2 minus 27 degrees. So from this T2 minus 27 is equal to 17 divided by 1.7 into 10 power minus 2. So this value is 17, 10 power minus 2 comes to numerator, it will become 100. So 1700 divided by 1.7. So that value is 1000. So T2 minus 27 is equal to 1000. So T2 is equal to 1000 plus 27, that is equal to 1027 degrees Celsius. So this is the final temperature at which the resistance of the resistor or the material is 117 ohm. So these are the 3 numerical problems from current electricity. In the next videos, I will give the solutions for other questions also. I hope these questions will be useful for you, those students who are preparing for board examination and CBSE oriented, for NEET and even JEE mains point of view also. Please subscribe the channel, share and like. Thank you.